Hi everyone, for today's lesson, we are going to learn how to graph quadratics in standard form. Our learning targets for today is for you to be able to say, I can graph a quadratic function in standard form using the vertex and the axis of symmetry. I can find the minimum and maximum of a quadratic function. I can convert a quadratic function into vertex form, or from vertex form to standard form, and I can convert a quadratic function in intercept form to standard form. So we are going to go from one form to another form by the very end of this lesson. So standard form of a quadratic, that is y equals ax squared plus bx plus c. In our previous forms that we have learned about, we always had a parentheses. Whether it was vertex form, had the parentheses where we had an x minus h inside, or in intercept form, we had the x minus p and x minus q to help us identify the x-intercepts. Standard form has no parentheses in it at all. So this is still, the graph is still a parabola. So the graph of y equals ax squared plus bx plus c is going to still be a parabola that still has an axis of symmetry, but that axis of symmetry is going to be x equals the opposite of b over 2a. Now, some of you might recognize that opposite of b over 2a that comes from the quadratic formula that you learned about when you were in Algebra 1. I want you to read this as the opposite of b, not negative b, the opposite of b. So the opposite of b all over 2 times a. That is going to be your axis of symmetry. Remember that that axis of symmetry is the x coordinate. So it has a vertex with an x coordinate of the opposite of b over 2a. So that is the x coordinate of your vertex. We would plug that value in order for us to find what the vertex is. So our vertex will be located at the opposite of b over 2a, comma, some y value. You'll plug that value into the function and then solve for y, or solve for whatever value that it's given. So this might be called something else other than y. What's really cool about standard form is that you can identify the y-intercept very quickly. It is your c value. 0c is the y-intercept. Now, please be careful. A lot of kids get this confused with vertex form, where we're adding a number at the end, and that's the y-intercept. Remember that in vertex form, when you add a number at the end, that is the y part of the vertex. So just be careful. This one has no parentheses, and it has new sets of rules. So your c value, that is the y-intercept of your graph. So right here, you'll notice a y-intercept is the location on the graph that crosses the y-axis. The graph will open up if a is bigger than 0, which is another way of saying a is positive. And it will open down if a is less than 0 or a is negative. And that is the same exact rules as what we have been working with the entire time since we have been in class. The other thing that I want to emphasize is that the axis of symmetry is always going to be a vertical dashed line, and we always write it as x equals. It's just this time it's going to be x equals the opposite of b over 2a. So whenever we are graphing or while using standard form, here are the steps that you will need to do. The first thing you want to do is identify what the axis of symmetry is and make sure that you graph it. So remember that the axis of symmetry is the opposite of b, x equals the opposite of b over 2a. That is going to be our first step. And what I'm going to do is I'm going to do each step in example number 1, going line by line. So since this is the first step, I'm going to identify my axis of symmetry first. One thing that's helpful is to identify what a equals, which in this case it's 2, what b equals, which is 6, and what c equals, which is 3. Now, if these had minus signs, we would have negative numbers for our A, B, and C. So our axis of symmetry is x equals the opposite of b. The opposite of a positive 6 is a negative 6, divided by 2a, 2 times 2. So this is negative 6 divided by 4, and I'm going to simplify that even further into negative 3 halves, or negative 1.5. So x equals negative 1.5 is our axis of symmetry, and I am going to graph it. I strongly recommend that if you have a highlighter with you, use a highlighter or some other color. I think that it's really helpful because it helps you to remember to always graph your axis of symmetry. It's the first step in this type of problem, but I'm just putting it out there. So here is negative 1 and 1.5. So that's going to be in between negative 1 and negative 2. And I'm going to make it a dashed line, not a solid line, because it is not part of the graph. It is more of a guideline. Step 2 is we are going to find and plot the vertex. So that is our step 2, find and plot the vertex. Now recall that the x value of the vertex is the axis of symmetry. And we are going to substitute this value of x, the axis of symmetry, in to find our y value. So we already know the x part of our vertex is negative 1.5. These two pieces, the axis of symmetry and the x part of our vertex, are the same exact values. Now we need to find our y value, and in order for us to do that, we are going to substitute negative 1.5 directly into our equation. So this is what it's going to look like. Y equals 2 times parentheses negative 1.5 squared plus 6 times negative 1.5 plus 3. Now please be very careful. The area where students make the biggest mistake is this first term. According to the order of operations, you have to square a number before you multiply. So make sure that you take care of the parentheses first before you multiply. That is the biggest error that students will make. So I'm just going to take out a quick calculator. You can use any calculator to make this calculation, but I'm going to enter it into my calculator exactly as I see it. So I'm going to write 2 parentheses negative 1.5 squared plus 6 times parentheses negative 1.5 plus 3. I'm going to press enter, and I end up with negative 1.5. So negative 1.5 is my y value of the vertex, and I can write it as an ordered pair of negative 1.5, negative 1.5. And it says up here, find and plot the vertex, put the vertex in the middle location of the table. So I'm going to plot my vertex, which is at negative 1.5, negative 1.5. So it's about right here. And I'm going to put negative 1.5, negative 1.5 into the direct center of my table. Next, I am going to I'm going to plot 2 points where I'm going to choose two integer x values on one side of the vertex. And then I'm going to find, so if possible, use x equals 0 or the y-intercept if it's available. Technically, it's pretty easy to use. And then we're going to find corresponding y values. So what that means is I'm going to logically come up with some values. So I would probably recommend choosing negative 1 and 0, and then negative 2 and negative 3. And the reason why I'm choosing those values is because it's numbers on each side of our vertex and our line of symmetry. And I am going to substitute negative 1 into my function right here to help me to find my y value. So I'm going to write y is equal to 2 times negative 1 squared plus 6 times negative 1 plus 3. If you want to do this without a calculator, this is what you do. Negative 1 squared is 1. 2 times 1 is 2. 6 times negative 1 is negative 6. And then I have a plus 3 at the end. 2 plus negative 6 is negative 4. Negative 4 plus 3 is negative 1. So I'm going to plot the ordered pair negative 1, 1. In order for me to come up with another point on the other side, remember in a table there has to be symmetry in that table. So we should expect that these numbers will be reflective on each side. So this point of negative 1, negative 1 is a half unit away from the line of symmetry. So I'm going to count a half unit on the other side, and that's going to represent a reflection point on the other side. And this is located at negative 2, negative 1, which makes sense with my symmetry. Next, I love the fact that I have the ability to use 0, and I know that 3 is my C value, and that is the y-intercept. So what I'm going to do is I'm going to put in 0, 3, and I'm going to plot that point. This point is 1.5 units away from the line of symmetry, so I'm going to count 1.5 units on the other side, and I'm going to plot a point. This point is located at negative 1, 2, 3, 1, 2, 3. So negative 3, 3, which makes sense in our symmetry of our table. So we've reflected, so I did more than one step in one step. We reflected the points plotted in step 3 in the x-axis. You don't have to fill in the table with your reflected values. Just make sure that you do so on the graph. But I would recommend strongly that you fill in the table with your reflected values, just because I think that it's easier to see that symmetry if you do so. Next, step 5, we are going to draw a parabola going through our plotted points. So remember that your parabola is the shape of a U. So make sure that it's not a V, that it has like some curviness to it, and just do the very best of your ability to make sure that you draw it in a curvy kind of way. So I'm going to emphasize once again and make this note that this is the y-intercept, and we got this value because it is the C value of our equation. All right, next we're going to identify the domain, which the domain for all quadratics is all real numbers. And our range in this problem, well, we have a minimum value and it is pointing up. So that minimum value is located at negative 1.5. Remember, it's always the y part of your vertex. So I'm going to say negative 1.5 going all the way up to arrows pointing to the top. So negative 1.5 to infinity. You can also write this as y is greater than or equal to negative 1.5. Our end behavior is going to be as x approaches positive infinity, that's looking to the right, we have an arrow pointing up. This function is called y. So I'm going to make this y approaches positive infinity. And as x approaches negative infinity, y approaches positive infinity. Remember that as x approaches negative infinity, that's the left side of the graph. All right, let's go ahead and move on to the next page. This next page is full of pairs and solos, so this is something that we are going to be working on the next time I see you in class. So if you would like to get these problems done, you're welcome to do so. If you want to work on them when I see you next time, that's perfectly acceptable as well. Let's go ahead and move on to the next page. So we've talked a lot about maximum and minimums going all the way back to absolute values. So now we're going to just put it down in words. Recall that a minimum and maximum is always the y coordinate. So we will have ourselves a minimum value whenever the graph is pointing up, and we will have a maximum value whenever that graph is pointing down. And it always feels so counterintuitive. We think of like minimum is negative, so it's pointing down, but it's actually all about where is it located with respect to all of the other points on the graph. So remember that this y coordinate is the max or min, and it's based on our a value. If our a value is bigger than 0, meaning that it's a positive number, then that means that we will have a minimum value. And if the a value is less than 0 or a negative number, then we will have a maximum value. So what we want to do in example number 2 is we want to tell whether the function of y equals 2x squared minus 6x plus 8 has a minimum value or a maximum value, and then we want to find what that value actually is. So what we want to do is we want to analyze our a value, and our a value in this case is 2. This is a positive number, so that means that our parabola is going to be pointing up, and we will have ourselves a minimum. And that minimum value, that's what we need to find next. So remember that minimum or maximum is always the y part of our vertex. So in order for us to find our vertex, remember that your vertex is always going to be located at the opposite of b over 2a comma y whenever we are given an equation in standard form. So that's what we need to do. Our a value in this case is 2. Our b value is located at -6. So it's at -6. So I'm going to use these values to identify my x coordinate. That is going to be the opposite of b. So the opposite of -6 is +6 divided by 2a. So that's 2 times 2. And so this is going to be 6 over 4, which is 3/2, or in other words, 1.5. So in terms of my vertex, I know that my vertex, so far, I have 1.5 as the x coordinate, and I now need to find what the y coordinate is. So what I'm going to do is I'm going to substitute 1.5 into my function, and I'm going to write y equals 2 times 1.5 squared minus 6 times 1.5 plus 8. And I'm going to put this into my calculator exactly as I see it. So I'm going to write 2 times parentheses 1.5 squared minus 6 times parentheses 1.5 plus 8. And when I do that, I end up with 3.5. So y is equal to 3.5. That is the y part of our vertex, and therefore it is our minimum value. When I see you next time in class, you will do the solo. So let's go ahead and move on to the next topic, which is converting from intercept form to standard form. So converting from intercept form to standard form, let's remind ourselves of what intercept form is. Intercept form is y equals a times x minus p times x minus q. And we're going all the way to standard form, which is y equals ax squared plus bx plus c. Now remember that we're going from parentheses to no parentheses. So we're going to be using some algebra work that we haven't used in a while, but we essentially need to get rid of the parentheses. Now the best approach for getting rid of the parentheses is to either use FOIL or the distributive property. Now what I'm going to show you really quick is something that I think helps a lot of students out, and that is if I asked you to multiply 3 times 4 times 5. I know that sounds very basic, but if I asked you to multiply 3 times 4 times 5, that process would be 3 times 4, which is 12, and then we would take that number and multiply it by 5. 12 times 5 is 60. That's one way that you could multiply. Another way, 3 times 4 times 5, is you could multiply 4 times 5 to get 20. So this is 3 times 20, and 3 times 20 is also 60. The point of what I'm trying to show here is that you are multiplying two pieces together, and those two pieces, when you multiply, turns into one piece, and then you just keep going. We're going to use the same exact process for multiplying here. So one approach that you can do is you can distribute 3 to each term, making this y equals parentheses 3x plus 6, and then we're going to FOIL that with x minus 5. Now I said the word FOIL. If you remember that FOIL means first times the first, outer times the outer, inner times the inner, and last times the last. So let's go ahead and do that. I'm going to multiply my first term, which is 3x, times my first term, which is x, to get me 3x squared. Then I'm going to multiply 3x times minus 5, That's my outer times the outer. That's minus 15x. Inner times the inner, so 6 times x is plus 6x. And last times last, so 6 times negative 5 is minus 30. Combining my like terms in the middle, my answer is going to be y equals 3x squared minus 9x minus 30. We stop here. This is standard form. You do not need to factor it anymore or bring out a 3 or anything like that. So that is one approach. And so I'm going to put a little number 1 here. Another approach is you could have foiled your 2 parentheses first to make this y equals 3 times a larger parenthesis. And you could have done x times x to make this x squared, x times minus 5 to make it minus 5x, 2 times x to make it plus 2x, and 2 times minus 5 to make it minus 10. Cleaning up this problem, this is y equals 3 times x squared minus 3x minus 10. And now we can distribute that 3 to all of our terms and end up with y equals 3x squared minus 9x minus 30. Both ways will get you the exact same answer. It just depends on which way you like better and which way you're more comfortable with. I personally do not care. So that is going from intercept form to standard form. Example number 4 is going from vertex form to standard form. So let's go ahead and remind ourselves of vertex form. Vertex form is y equals a times x minus h squared plus k, and we're turning that into y equals ax squared plus bx plus c. Now, the area where kids make the biggest mistake is with this square. And what does it mean to square something? Well, it means that we are multiplying by itself twice. And so this parenthesis needs to be written out twice. So an error that a lot of kids make is they distribute the square to each term. And I'm going to write like I'm yelling at you. I'm not yelling at you. I'm just wanted to have some emphasis. Do not distribute the exponent. Do not distribute the exponent. I don't know. Maybe I need to put that in orange. Do not distribute the exponent. Whatever you do. Instead, what we are going to do in this problem is we're going to rewrite this as f of x equals negative 5, and x plus 2 squared means x plus 2 times x plus 2, and then plus 8 is on the outside. Do not distribute the exponent. Okay. So I am going to rewrite this as f of x equals, and you have your choice. You can distribute the negative 5 to the first parentheses. You can take care of the parentheses and then distribute 5. The choice is up to you. I personally do not care. What I'm going to do is go from left to right because for me that makes the most sense for my brain. So I'm going to go negative 5 times x, which is negative 5x, negative 5 times 2, which is minus 10. And I'm going to write x plus 2 in the second parentheses and then plus 8. Now I'm going to FOIL the plus 8. It kind of hangs out on the end until I've gotten rid of all of my parentheses. So I'm going to distribute negative 5x times x is minus 5x squared. Negative 5x times 2 is minus 10x. Negative 10x times x is minus 10x, and negative 10 times 2 is minus 20, and I'm going to bring down the plus 8. At this step, we need to combine our like terms, so I have negative 5x squared, negative 10x minus 10x is minus 20x, and negative 20 plus 8 is minus 12. There is your answer. The remaining problems are pairs and teams, so I am going to leave that for you guys to work on when I see you next time in class. That is the end of today's lesson. If you have any questions over what I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.